Round three after two internet disconnections, so let's keep on going right here. I have broken down this integral. I applied the conjugate. I am splitting up the conjugate across the numerator, 1 minus x. I've got my 1 minus x, keeping that denominator between both. I'm going to recognize that this is my appropriate trig sub for both of these integrals right here. So I'm going to go ahead and do my x equals just straight, x equals a sine theta, x equals sine theta, and therefore dx equals cos theta, d theta. And if I do this, then my new integrands become the square root of 1 over 1 minus sine squared. Dx is cos theta d theta. My second integral here is going to be x is sine theta, integral 1 minus sine squared theta. Again, dx is cos theta d theta. Now I can go ahead and simplify these guys. 1 minus sine squared is cosine squared. Well, look at what this is giving me here. Square root of cosine squared is cosine times cosine on the numerator. Well, it's just the integral of 1 d theta. That's just theta. On the other hand, over here, I have my a similar looking thing right here. 1 minus sine squared is cosine squared. Square root of cosine squared is cosine. Cosine divided by cosine cancels. And this leaves me just with a sine of theta. Notice that this minus will now switch to a plus, and we're just going to get plus cosine of theta plus c. And it looks like the only thing we've got to do right here is just swap back in our appropriate terms right here. We did the substitution x equals cosine theta. Oh, nope, that's not what we did. And I want to give myself a little more room right here. We did x equals sine theta. So that tells me that we should have that theta is sine inverse of x. And another thing is that I know I can write this as x over 1. So the two things I'm seeing are, one, this was just our direct antiderivative for sine inverse. Technically speaking, this is sort of one that, in a sense, you sort of know that one. I just know that most of us forgot our antiderivatives for our inverse trig functions. But this is exactly the derivative of sine inverse, this integrand right there. And that's all we got was sine inverse, right? This guy right here, it looks like we need to get a plus cosine of theta, right? And so I want to draw my triangle so I can get the cosine. Sine was x over 1, which is opposite over hypotenuse, so opposite hypotenuse, so that is a square root of 1 minus x squared. So it looks like cosine of sine inverse of x plus c. It looks like the cosine of theta in this case is square root of 1 minus x squared. So it looks like our total answer for this guy is right here. So there we go. We did one version of this problem right here, and we did this by guessing a conjugate. And when I say guessing a conjugate, what I mean is this wasn't even super obvious to me that this should be a conjugate. Even if it wasn't obvious to me which conjugate I wanted to hit it with, but I picked the one that seemed most reasonable. I got myself into a trig sub format right here, and I was able to kind of wrap up this problem. The question is, what would we do if we weren't going to do that? And so here's actually kind of what I'm thinking to myself right here is this. Rather than me doing this problem a different way, I think that I was going to do this another way, and I'm just going to write this right here. But I think you should instead. And here, I'm going to tell you exactly how you should start this problem. That is what one of your homework problems is going to be for our week 6 homework right here. Is saying, I want you to do this integral, but I've already done it one way and I don't care to see it that way again. I want to see an alternate route to the solution to this integral right here, square root of 1 minus x over 1 plus x. And what I'm telling you you're going to do for your strategy is, going back up to our strategy guide, is exactly what we suggested right here. Remember that our u sub suggestion right here, if there's a quadratic under a rational, a trig sub, or otherwise, u sub the whole radical expression. That is my suggestion here to you. U sub the whole radical expression, which is the entirety of the integrand right here. So as one of our, I'm deciding this now partially in the interest of time and partially because this is a pretty hard one right here that requires a lot of steps and a lot of manipulations right here, is this will be one of your like 2 or 3 homework problems I'm going to assign for the week 6 homework right here. So if you're watching this video right now, before the homework's been posted, know that doing that will be one of your problems right here. Otherwise, it will obviously be listed regularly in the written homework assignment right here. But the problem will be, determine the value of the integral, the square root of 1 minus x over 1 plus x dx. But you can't, or you're not allowed to use the conjugate and trig sub technique that I did right here. I've already done that way. I want you to do this one by u subbing the entire radical expression right here. I have worked this one out right here. I did come into a, I have to fix one thing. I'm apparently off by one constant coefficient, but just because I apparently didn't like distribute something at some step along the way. But this will be, to conclude today, I'm not going to do this one the second route. I want to see if you can do this one the second route. So go ahead and give this guy a shot right here. And remember to be persistent to the point of being aggressive. Don't give up. I'm 100% confident that you have the skills required to do this. This one takes a ton of different techniques to get there. There's so much stuff to this one right here. It's not going to be as easy of a route as this one, although honestly, this wasn't an easy route either. This required me to make some sort of like, I don't know, not quite guesses. It got easier towards the end, but still, I know that this trig stuff's slightly uncomfortable to be doing. Identifying conjugates and performing them and picking between them is not a thing that I think a lot of us have great confidence in. Get over it. I say that in the nicest, most positive way right there. I believe in your ability to do this. So here we go. Here's one of your homework problems. That's how I'm going to wrap it up today. Do this integral by starting with this u sub. Right away, you should say to yourself, how the hell am I going to get du? Yep, that's going to be one of the challenges of this right away. Du is not obvious to construct right here. Maybe you can think about a clever way to compute du without directly taking the derivative of this function right here. And that's how I'm going to end it today. Sorry about the multiple internet outages here. I hope my videos aren't too terribly chunky right here. Otherwise, so next week, we're going to do 2 interesting things next week. Next week, we're going to hit 7.7 and 7.8, which is going to give us approximating integrals. So this is saying, if we have an integral that we can't do, or that we want to come up with a numerical approximation for, how should we approximate the value of that definite integral? The other thing that we're going to look at is in 7.8, we're going to say things like, don't you think it's weird that we haven't brought infinity into our integration yet? Meaning, what happens when we integrate over bounds of infinity? Also, what happens when we integrate a function that has y values that tend off towards infinity over the bounds of integration? So both 7.7 and 7.8 are going to deal with some sort of specifics associated with definite integrals. So we're going to have bounds on all of our integrals in 7.7 and 7.8. So we're going to get approximations of integrals, and that's going to kind of come back to like our Riemann sums and stuff like that. So you guys will have some comfortability there. And then in 7.8, we're going to see some things. And 7.8's not going to really be that bad, but it's some things where it's like, you got to be careful because you can be tricked. But if you're careful, it's easy to do. So I don't think 7.7 and 7.8, I think those are easy relative to how difficult the first 4 or 5 sections of this chapter have been here. And that will be our conclusion to chapter 7. Chapter 8, I would straight up just call fun. It's a bunch of like really cool things where you're going to be like, dang, I didn't know that I was able to do that with just the calculus that I know right now. And that's the feeling that I get when I do all the chapter 8 application things that are out there. So I really appreciate chapter 8 as sort of like fun things that you can now do now that you are maybe I shouldn't call you a master of integration yet, but definitely on the road to mastery of integration. What are some cool things that we now are able to do? So I will see you guys with better internet next week for section 7.7. See you guys then. Have a good one.